Hello. So for this video, we will be talking about other methods for the elimination of arbitrary constants or the formation of DE. Okay, so for the third method, we have the successive differentiation. Successive, spelling is wrong. Okay, so in this case, we will, the process here is, well, to differentiate as many as possible depending on the number of arbitrary constants. Okay, the goal is of course to eliminate the arbitrary constants as well, and this may involve isolation and substitution during the process. Okay, so let's have an example here. Y is equals to c1 plus c2 e raised to 3x, right? So we have two arbitrary constants. We have c1 and c2. Okay, now in order to eliminate C1 and C2, of course, we will call this one. We will differentiate the equation two times, right? So for the first derivative, okay, for the first derivative, C1 plus C2 e raised to 3x, okay, directly differentiating C1 will be eliminated. Okay, so we have the derivative of y is y prime. Now my tip here is to be comfortable with using primes. Okay, for example, the derivative of y is y prime and the other function is x. So since the equation is written this way, more likely y is the dependent variable and x is the independent variable. So as long as you have determined your primes, okay, you're the one who will determine what is the equivalent of a prime. So in this case, my y prime will be equal to dy over dx because implicitly differentiating, this one should be, so dy, right, is equals to, so c1 will be 0, c2 e raised to 3x. So e raised to 3x, the derivative of that will be 3, right? c2, okay, e raised to 3x dx because this is the derivative of x. Now, this should be the result upon using implicit differentiation and then multiplying or transposing dx to the other side. We will have dy over dx here, which is equal to y prime. So we will have y prime here 3 c2 e raised to 3x. Okay, so I hope you will develop the comfort in using primes for the derivatives. Okay, now for the next, what do you call this one? For the next step, we need to do another derivative in order to eliminate C2. So we can do isolation here. We can also do substitution. So I will show you both so you can at least sense which method will be more comfortable for you. Okay, so first I will try isolation. Okay, so we will isolate 3C2 because these are all constants. So upon differentiating, this will be equal to 0. So let's transpose e raised to 3x, so y prime over e raised to 3x is equals to 3c2. Okay, so this one is a bit off. You can do, what you call this one? You can do quotient rule here, or you can also do e raised to 3x will be transposed, rather rewritten as e raised to negative 3x, so that we can do product rule. So whatever is more comfortable for you, you can use either product rule or quotient rule. I will be using the product rule because I'm more comfortable with that. So differentiate both sides. Okay. So product rule is UV, rather the derivative of UV is equals to UdV plus PdU. So U will be y prime, V will be e raised to negative 3x. So y prime times the derivative of e raised to negative 3x is negative 3 e raised to negative 3x. Alright, then plus v du. So v is e raised to negative 3x. Then the derivative of y prime will be y double prime. Then the derivative of 3c2, which are all constants, will be equal to 0. Okay, now rewriting this one. Rewriting this equation, we will have negative 3y prime. Okay, but if we will notice, both terms has e raised to negative 3x. Okay, so we can eliminate e raised to negative 3x on this by multiplying e raised to 3x. Alright, so that e raised to 3x minus 3x e raised to 0 will be equal to 1. Or if you're not comfortable with this one, we can do this. Okay, 1 over e raised to negative 3x. Okay, so again, 1 over e raised to negative 3x is also equal to e raised to 3x. So whichever you are more comfortable, so that's what you should be using. Okay, so this one will now be cancelled, right? Cancelled. Of course, multiplied by 0 will be 0. So negative 3y prime plus y double prime is equal to 0. Or rewriting this one, we will have y double prime minus 3y, apologies, y prime is equal to 0. So this will be our answer. So this is our DE. From y is equals to c1 plus c2 e raised to 3x. Right? So the method here is successive differentiation. Right? So I hope the method is clear. Let's have another example. Okay, so another example here is y is equals to ax squared plus bx plus c. So this equation is a, what you call this one? Parabola. Alright. So for this, we have three arbitrary constants. Okay, so meaning we need to do the successive differentiation. Okay, so for the first derivative, right, we don't need to do any manipulation for now because c is already separated. So upon differentiating this one, this variable c or this constant c will be equal to 0. So y prime is equals to ax squared, derivative of ax squared will be 2ax, right? Derivative of bx will be b, then c will be 0. Now, b is also separated, so we don't need to do any manipulations. We can directly derive, right? So y prime, the derivative of y prime will be y double prime. The derivative of 2ax will be 2a, okay? And then b will be 0. So again, 2a is also separated already or isolated already. So one more differentiation, we will have y triple prime is equal to 0. Okay? So this is our d. Right? So as long as the you call this one, as long as the variable is already separated, you can differentiate. Okay? Or isolated, yeah, you can differentiate. You can also apply substitution here. If we will go back to our previous example, okay, okay, so let's go back to y is equals to c1 plus c2 e raised to 3x. Then our first step earlier, which was to derive, because c1 is already separated, and we are stuck with c2. And we want to eliminate c2. The earlier example that we had, we used isolation method. Okay, but here I want to show you the substitution method. Okay, now how to determine how to do substitution. It's more of a practice kind of thing. So if you're more experienced in solving these kinds of equations, you can start seeing some manipulating techniques or manipulation techniques that will make the solving more easier. So I don't think I can uh, recommend any shortcuts. There's no shortcut here. You have to solve, 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 solve in order to develop that sense of uh, that sense of comfort in manipulating our equations. Okay, so what do I mean by that? Because we want to eliminate C2, so we need to find a substitution for C2. Okay, now I will try my best to explain the thought process here, but you see, e raised to 3x makes this equation a bit more complicated to manipulate. Okay, so if we can also substitute or find the substitute for e raised to 3x as well, it may make the equation a bit more easier to manipulate. Okay, so what do I mean by that? If we will go back to our original equation, which is y is equals to c1 plus c2 e raised to 3x, right? If we will separate c2 e raised to 3x, we will be having y minus c1 is equals to c2 e raised to 3x, right? Now, these two are our problems so far. C2, we want to eliminate C2, and then e raised to 3x makes the solution a bit more complicated, or the process a bit more complicated. So if we will use this as the substitution for C2 e raised to 3x, we will have this one, right? So we will have y prime is equals to 3 times y minus C1 instead of C2 e raised to 3x. What benefit does this bring us? Okay, by distributing 3, we will have 3y minus 3c1. 3c1 is already isolated. So by differentiating this one, we will have, okay, I will resume here. We will have y double prime is equals to 3y prime. Then 3c1 is already 0. So by transposing 3y prime to the other side, we will have y double prime minus 3y prime is equal to 0, which is also our answer earlier. Okay, so that's what I'm talking about when I said we can apply both substitution and isolation in the third method, successive differentiation. Okay, so this is for method number 3. To spoil, we have 5 methods here for the elimination of arbitrary constants. So see you on the next video.